Students, welcome to s.mathguru classes. Our main discussion is Jacobians. Already solved some problems. Now we consider the remaining problems, and these are important for any engineering courses. It may be first semester, second or third semester, but these are most important for engineering courses. And these are important for B.Sc major also, mathematics major. Now we consider one problem. Show that ax square plus 2 is xy plus by square, capital Ax square plus 2 capital A is xy plus capital By square are independent unless A by A, B by B, H by H. We have to show this. These are independent unless this A by A, B by B, H by H. Now we want to solve this problem. Solution is start. So first we consider this problem. Let u equal to ax square plus 2xy plus by square. First we find del u del x. Del x ax square 2xy plus by square. This is twice ax twice hy plus 0, because we differentiate partially with respect to x. This will be 0. So we get twice ax plus 2hy. Next, del u del y. Del y ax square plus 2xy plus by square, and this is x, this will be 0, 2x plus 2by. So this will be 2x 2xx 2by. So u is over. Next to consider another v. Let v equal to capital Ax square to capital A is xy plus by square. Del v del x. This is del x ax square 2xy plus by square, and this will be twice ax plus 2hy plus 0. This is twice ax 2hy, and del v del y. This is del y ax square 2xy plus by square. This is 0, 2x plus 2by, and we get 2x 2by. So we get del u del x del u del y del v del x del v del y. Now u and v will be independent if there exists a relationship between them, and in that case del uv del xy, that means Jacobian uv with respect to xy, should vanish identically. So that is what we get, that is del uv del xy equal to del u del x del u del y del v del x del v del y, this equal to 0. Now putting the values, del u del x we get twice ax plus 2hy, and del u del y 2hx plus 2by, and this is same 2ax plus 2hy plus twice by, this equal to 0. We get this one 0. Now from this 2 common, or this into this minus this into this, we expand this, twice ax plus 2hy into 2hy plus 2by minus 2ax plus 2hy 2hx plus 2by, this equal to 0. Now from this 2 common, here also 2 common, and this 2 common, dividing by 2, 4 on both sides, then we get ax plus hy plus by, ax plus hy, hx plus by equal to 0. So if we taking 2 common, here also 2 common, then 4, and here 2, 2, 4, dividing both sides by 4, we get this one. Now simple calculation, a is xy, ab xy plus h is y square, hb y square minus a is x square, a is x square minus ab xy minus h is xy minus b is y square equal to 0. So we get this one, and taking x square common here, and where we get x square, so this should be x, here also we get x and is x. So this is a is x square and ab xy, this is h is xy and by square, and here these are remain same, and from this and this x square common, we get a is minus capital A small is x square plus xy, here we get xy, ab xy, here xy, ab xy, is xy, is xy, and this is capital A is small h, these two are cancel, and from these two taking xy common, then ab small a capital B, capital A small b xy, and from this hb b is y square equal to 0. We get this result equal to 0. Now the variables x and y are independent, and as such the coefficient of x square and y square should vanish separately. So this is variables are independent, as such the coefficient of x square and y square should vanish separately. That means this is the coefficient of x square, this is the coefficient of y square, this vanish separately. Now that means therefore we get small a capital A is minus capital A small a is equal to 0, and small a is capital B, B is this equal to 0, and from this we get a is equal to a is small a capital A is equal to this, or we can write A by capital A, H by capital H. And from this also we can write HB equal to BH, or we can write H by H equal to B by B. We get this. If we joining this, therefore we get A by A, that means B by B, H by H. We can write this one, or this A by A, this is H by capital H and B by capital B. B by capital B. If we joining this, A by A, H by H, H by H, this. So this and this equal. We get this one. So we get this. Hence A by A, H by H, B by B, and these conditions also make the coefficient of xy is xy 0. If we using this condition and putting here, then coefficient of xy also 0. If we putting the values, then also we get 0. Hence we get A by A, B by B, H by H are the required conditions. This is the required conditions, and this is our proof. Show that this. Ultimately we get this one. Very easy solution, not difficult, just simple calculation. Consider another problem. If u equal to x plus y by x minus y and v equal to xy by x minus y whole square, find del uv by del xy. That is Jacobian uv with respect to xy. Are u and v functionally related? If so, find the relationships. Functionally related means if Jacobian is 0, then functionally related. Now we consider this problem. Solution is start. Here u equal to x plus y by x minus y. Del u del x del x x plus y by x minus y. This is x minus y whole square quotient rule. X minus y del x x plus y minus x plus y del x x minus y. So we get this, and if we calculate x minus y whole square, x minus y 1 plus 0, x plus y 1 minus 0. So this will be x minus y whole square, x minus y minus x minus y, x cancel, minus twice y by x minus y whole square. We get this one. So del u del x is this. Next we find del u del y. Del u del y, the same method, del y, x plus y by x minus y. This is denominator whole square quotient rule, x minus y del y x plus y minus x plus y del y x minus y, and this will be x minus y whole square, x minus y, this is 0 plus 1, x plus y, 0 minus 1. Then this is, we get x minus y whole square, and this one x minus y, and this is minus, and this minus will be plus, x plus y, and y cancel, we get twice x by x minus y whole square. This is del u del y, and del u del x already we get, del u del x is this, minus, I rewriting this, twice y by x minus y whole square. We get this. Next we find v. V equal to given xy by x minus y whole square, del v del x, del x, xy by x minus y whole square, and this is quotient rule, x minus y whole square, x minus y whole square, del x of xy minus xy, del x of x minus y whole square. We get this. Now this will be x minus y whole square, whole to the power 4, this is 4, x minus y whole square, this is y into 1, xy, if we write directly, 2 into x minus y, this is 1 minus 0, and x minus y whole to the power 4, from these two terms x minus y is common, y into x minus y common, y into where y x minus y common, then we get x minus y minus twice x, we get this, and this is 1 is cancel, we get x minus y whole cube, x minus y whole cube, and this is minus x, y into minus x minus y, we get this. So del v del x, and from these two taking minus sign common, minus y into x plus y by x minus y whole cube, we get del v del x. Again we find del v del y, del y, v means xy by x minus y whole square, and again using quotient rule, x minus y whole square, this whole square, x minus whole square y whole square, del y xy minus xy, del y x minus y whole square, and this is x minus y to the power 4, x minus y whole square into x minus xy, 2 into x minus y into 0 minus 1, we get this, and x minus y whole to the power 4, and from these two terms x and x minus y common, we get x minus y, and here minus minus plus, x also common, twice y, plus twice y we get, and this one cancel, we get x minus y whole cube, x into x plus y. This is x plus y we get. So del v del x we get this answer. Now we find, just we get del u del x, del u del y, del v del x, del v del y. Now we find this Jacobian. Now del u v del xy. By definition we get del u del x del u del y del v del x del v del y. Now putting the values, del u del x means minus 2y by x minus y whole square, del u del y twice x by x minus y whole square, and del v del x minus y into x plus y by x minus y whole cube, and this one x into x plus y by x minus y whole cube. This one we get. Now we expand this into this, minus this into this. If we expand, this is minus 2xy, 2xy x plus y by this into this, x minus y to the power 5, and this minus minus plus 2xy x plus y by x minus y whole to the power 5. So we get this one, this is we get. Now both are like terms, this will be 0. So what we get? Jacobian is 0. Since what we get, since Jacobian of u comma v with respect to xy is 0, therefore u and v are functionally related. U and v are functionally related because Jacobian is 0 we get. Now if so, find the relationship. Now what is the relation between u and v? We have to find relation between them. Now second part we consider. Second part, what is the relation between them? Now u equal to, here given x plus y and x minus y, this one given. If we squaring both sides, u square equal to x plus y whole square x minus y whole square, we get this. But we know a formula from lower class, a plus b whole square equal to a minus b whole square plus 4ab. This is a formula. A plus b whole square equal to a minus b whole square plus 4ab. So using this formula here, denominator remains same, and a plus b whole square, this is a minus b whole square plus 4ab. We get this. This implies u square equal to, if we separate this, x minus y whole square x minus y whole square 4 into xy x minus y whole square. If we separate this by this by this, we get this one. So this implies u square equal to 1, this is 4, and this is nothing but our v. This is the v. We get this is v. So this is the relationship between them? Answer is this one, our answer. This is the relationship between U and V. This is our answer. These are very easy solution, very interesting, very nice also. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.